This is a follow-up to the curve fitting video. I suggest you look at that first. It says, let's take a data set of a certain number of points and let's interpolate some values between data points or extrapolate beyond. Let's get started. Okay, we'll begin by having 5 pairs of data points, and there are multiple ways you can enter it. Here's a way you can enter as a matrix. It is a matrix which consists of 2 vectors. There's the x component and there's the y component. Hitting enter, they look like that. Another way is to explicitly write it all out as 5 rows, 2 columns, and then listing all the data points within the matrix. To figure out what the endpoints of the x values for these 5 data points, I'm going to create x sub 0 and x sub f. X underscore underscore 0 to the right, comma x underscore underscore f, cursor to the right, colon equals m11, that will pick out the first element, comma m row minus 1, comma 1, that will pick out the last one. How many rows of data I have, I'll call that n, n colon equals upper bound of m. Oh, look, I get 2 values, the number of rows, the number of columns, so therefore n really is equal to n, the first element. At this point, let's create a polynomial fit with these 5 data points. Therefore, this will be on the order of 4. I'll call this polyfit under curve, colon equals. It is in the curve fitting package. There's lots of stuff in the curve fitting package, although I tend to use fit from the statistics package to do curve fitting, colon dash polynomial interpolation of m as a function of x. And then we can make a function out of this. Polyfit function is make function of the polyfit curve with respect to x. At this point, we can test to see whether our polynomial fit works by saying, let's look at the value when x equals 5. Do I get a value of 2? Polyfit f of 5, and it responds with 2. Oh, what about a value between 5 and 6? Polyfit fit f of 5.5, and the value that's going to occur between 5 and 6 is 3.74. Finally, let's plot our data. We'll use the scatter plot of data using a symbol size of 25. We will do a standard fit of our function from the minimum to the maximum, and then we will also display the two, changing the axes to normal and changing the size. As you can see, it fits the polynomial perfectly because there are 5 data points, and this is a 4th order polynomial. Another way to make a curve is through a spline fit, and for many situations you may find a spline fit more useful, particularly in terms of trying to calculate derivatives of data points. So how do we make a spline fit? Okay, we'll call this spline fit. It is also in the curve fitting package, colon dash, not surprising, it's called spline. Open parentheses, you pass it the data, in this case m, and you say you want to make a fit as a function of some variable. In our case, it's x. As you can see, it uses, in this particular case, 3rd order polynomials, which you can control as what order, to create a map of the curve that fits through all 5 points. I'm going to make a function out of this. Make function spline fit as a function of x, and I will not plot it. Next, I'm going to make a plot of our spline fit, and again, you can write it out any way you want. And finally, I will plot all 3, the data points, the polynomial fit, and the spline fit on the same plot. As you can see, what the spline fit does in blue is it more naturally travels between all 5 points. The final activity for this video is I'm going to do something which you can get more information from the document associated with this particular exercise, this particular video. Select File, Open, Plot and Fit Data, and as you can see, what I have here is a way to use Excel tools import to import data and fit a curve that way. So I'll hit enter, import the data. Here's my fitting equation, do the statistics, extract out the equation and also the residual mean squared, make a function for my data and plot both the data and the fitting function. Put it all on one data and make a nice title, change the fonts for the labels, a nice legend, and you can see how using Excel data you can make a nice fitted curve to it. Being able to import data from Excel should be part of another video in the series, but this gives you an idea of how it works. The advantage of Maple is that it does a much better job than Excel to fit the type of curve that you want to your data. In addition, it allows you to add the type of spline fit or polynomial interpolation that Excel cannot do easily.